All right, definite integral. All right, you need to see it quite clearly by having the two numerical value at the both end of the integral sign. Okay, we will read this as integral from A to B. We read this integral from A to B. A to B of f. Okay, the number at the bottom, we read it first. A to B. Why we read it A to B? Because the value of your A is actually lesser than the value of B. So it's actually directional from A, from the left side, moving to the B, which is on the right side. So you do the integral. If you see this, there is no prime. Therefore, we have a capital F. The next step is, this is yesterday's work. The integrating is yesterday's work. So what is going to be the next step is substituting the B first, and then minus by substituting the A. There is no need to put in plus C. Okay, because it automatically will be cancelled off. Okay, automatically it will be cancelled off. Some property, this is quite important for you to know. If you are integrating from A to A of the function, it gives you 0. Simply because if you realize, if you have a function, okay, A to A is just a line under the curve, and area of a line is 0. Okay, that is the first thing you need to know. The A to A, if you are same thing, the outcome should be 0. Next, what we see here, the value of your AB, you observe the A and B, it is actually been swapped. It is actually negative. What does it mean? It is actually directional again. It is a directional. If you have your graph, whatever the graph is, your A to B, your going forward is positive. If you're going backward, it will be negative. Okay, so you need to observe carefully. All the time we think AB, but there are times you can be asked BA. And because of you've been conditioned as AB, you forgot. Okay, the negative shows you the direction. Next, if you have the K, as we know that K has no impact of the integral, you can just pull it out the person. You can just pull out the K. All right. You don't want to pull out and you want to leave it as what we've been doing. It is perfectly fine. Okay. Coefficient has no impact of integration. Okay. Next, if you have a lot of function, you can split them as many as you like. Okay, you can split, do the fx first and then do the gx. But normally what we will advise is you simplify first. In the future, especially you will do this when you do the area between two graphs. Okay, and area the two graph, you must simplify first rather than doing it separately. Okay, more work. And finally, you can split the integration as many components as you like, as long the value is in between. A to B, this case they already mentioned, C is between A and B. Okay, so that means if you are doing the integral, for example, 0 to 5 fx dx, You can split it to 0 to 1 fx dx plus integral 1 to 3, for example, fx dx plus integral 3 to 5 fx dx. You can do as many sub-component as you like. But we normally don't simply do this. It all depends later in application. It is on the basically used for the area between the graph. All right, example. The keyword will be evaluate. When it's asked to evaluate, normally your answer should be a numerical value. Integral 1 to 2 x squared dx. So first of all, open a big bracket. We know the integral x squared is you're gonna get x cubed over 3, and you're gonna substitute your 1, 2. Sub the 2 in, you're gonna get 8 over 3 minus 1 over 3. 8 minus 1 is 7 over 3. That's it. One more example. What is the integral of cos x? Integral of cos x is, you will get sine x and 0 pi over 2. So that's going to be sine pi over 2 minus sine 0. Sine pi over 2 is 1, sine 0 is 0. Answer is equivalent to 1. Okay, so that should be giving you e3x over 3 plus x for 1 over 3. Sub the 4, that will be e12 over 3 plus 4 minus, kindly use bracket, that would be e over 3 plus 1 over 3. So we can simplify a bit. Why not? Four minus 1 over 3, 4 is 12, so there's 11 over 3. Okay. The other one, this one should give you, actually the outcome would be ln modulus 3x plus 1, and you should have 2 over 3. 1, 2. If you substitute the 2 in, 2 over 3, ln 2 times 3, 6, 6 plus 1, 7. 7 is already positive, so it's ln 7 minus 2 over 3. Substitute the 1, that will be ln 4. 3 plus 1 is 4. So we have a common factor of 2 over 3. Then you will have ln 7 minus ln 4. Ln 7 minus ln 4, you should be able to get ln 7 over 4. So the integral will give you x4 over 4 to 3. Substitute the 3 in, 3 power 4 is 81. All right. 81 over 4 minus 2 power 4 is 16 over 4. So that gives you 65 over 4. Now, can we check this using the graphing calculator? For the GC, there are many ways to do it, but I'm just going to do it one way. You press your Maths. Okay, press your Maths, go to the option 9. Press 9. Maths, option 9. Press 9. I guess it speaks itself, right? It speaks itself. You enter the lower limit is 2, upper limit is 3. Function is x power to the 3. X power to the 3 dx. And then if you enter, you are able to get your answer. And if you want to change the answer to fraction, you press Maths, option 1. You press 1. 65 over 4. Our answer is correct. Integral of sine gives us negative cos 0 to pi. So that will be negative cos pi minus cos 0. Cos pi gives you negative 1 minus negative cos 0 also 1. Answer should be 2. We can check that with the GC. 0. Upper limit is pi sine x dx. Answer is 2. And the last one is integral of cos gives you sine x negative pi to pi. So that will be sine pi minus sine negative pi. Sine pi is 0. Negative pi also 0. Answer is 0. We can check again. Maths 9. Negative pi cos x dx. That is actually 0. It's actually negative 1.13 times 10 power to the negative 3. A very small value which is equivalent to 0.